Hello, Physics 131 students. This is Rose coming to you live from my home. And today I will be teaching you guys how to play with the circuit construction kit on PHET. There are lots of really cool components on this simulation that provides an insight on the flow of currents in a circuit. Circuits are basically loops that electrons can travel through when a source of electricity, such as a battery, provides electrical energy for it. Here on the left, we can see that this simulation offers all of the components that can be potentially found in a circuit. Here's a wire, and the wire makes up the majority of circuits because that's what carries the electric current in a circuit. It can be arranged in a series with only one path or parallel, which gives two or more paths for the current to flow through. Today, you guys are going to see me build a parallel circuit. Next, what we have here is a battery. This is going to be the energy supply for the circuit. This is a light bulb. The circuit that I'm going to build today is going to light this up. You can also set the resistance in ohms for the light bulb, and we'll see how that affects how bright it's going to be. Next, we have a resistor. This is going to regulate the flow of the current in the circuit. We can also set the resistance in ohms of these resistors. This is a switch. It basically just controls the flow of the current. We can use the switch to inhibit or initiate the flow, turn it on or off in simpler terms. When we scroll down, we can see that we can also put a fuse in our circuit. This is so that if we reach a dangerous level of current within our circuit, the fuse will break the current and help avoid it from catching fire. The rest of the items on the left are just stronger versions of the above components and other forms of conductors that you can use if you wanted to, but I don't want to, so we're not going to use that today. On the top right corner, we can choose two different ways to show the current in the circuit, and below that we have a voltmeter, which is used to measure the voltage of an element in our circuit. Oh god, excuse me. And we have an ammeter for measuring the current of the path. The voltmeter must be parallel with the circuit in the element in order for it to work. I was waving this around in all sorts of different positions when I was learning to use this, and I couldn't figure out for the life of me as to why it wasn't working. In addition to that, in order to use the ammeter, this has to be in series with the resistor. And with that said, let's get to building our circuit. Okay, so this is a circuit that I built. When I connect this last wire here, it should power the light bulb, and I'll also be selecting the conventional current on the top right corner to show the direction of the flow of the current. It works, yay! Now I'm going to add a fuse and increase the voltage on the battery and try to blow it up just cause. Oh. Now, if the fuse wasn't there, like so, let's see what happens when I increase the voltage. When I was little, I used to force turn on the circuit breaker in our house whenever it would turn off, and I see now that that was very dangerous. Oh well, at least I didn't burn down the house. Anyways, that's all I got. I hope you guys enjoyed this video. Personally, I feel like the visual in this simulation has helped given me a better understanding on circuits, and I hope it helps many of you guys too. Okay, bye!